As you know, data extraction from documents is critical for businesses. So today I'm going to compare the 4 best free OCR tools that you can use right now inside of N8N and reveal which one shocked me with its amazing results. So I'm going to walk you through exactly what OCR is, and then we'll run through each tool and show you how they perform on real documents. And we're going to go through graphs, tables, and even handwritten text, and then demonstrate how to set them up inside N8N so you can start extracting from your images and your PDFs today. So let's dive in with our first OCR tool. But to follow along with the tutorial, go to school.com/scrapes, and you're going to come into the community classroom and you're going to hit up the resource hub. And inside this plug and play template library, you'll go to the operations template, which says OCR. And what you're going to do is just download this workflow JSON and then open up your N8N environment. And you're just going to create a new workflow and import that from file. That's going to open all of the different nodes that we're going to use today and test today to make it much easier if you want to test this at home as well. Otherwise, you can recreate this for yourself. So let's take a quick look at exactly what we're going to be extracting today. So the first one is just a capture from our website. We've then got a table of data. So we've got both a graph and some text here. We've got some handwritten sample that we're going to ask the OCRs to extract from. We've then got a quite illegible set of data in a table that's also handwritten. We've got some old stock charts from a newspaper. And then finally, we've got a long document that's 29 pages. So a multi-page document containing things like formulas, etc. And we're going to run through which models for free can tackle these today and how good each model is. So if I didn't make it obvious enough, OCR is effectively optical character recognition. So it's the ability to take a document like this on the left-hand side, which is a scan of a paper document, and actually convert it to something like this on the right-hand side, where we can actually search and index all of the information. So everything on the left-hand side is a physical scan, and on the right-hand side is an output from an OCR tool that has converted this into a searchable document so that we can store it and search it later. And you can see this table, for example, appears as this table over here, but now it's digital and now it's searchable, which is much more useful for our business than a paper document. So as I mentioned, optical character recognition converts images into text, or converts images of text rather, into machine readable, editable text data by actually taking the shapes and patterns of what it sees on the page and inferring what it thinks that letter or character is. OCR is used in all sorts of businesses, some that you'll interact with every single day. So for example, banks interact or have been using OCR for many, many years now, and they do over 20 billion checks annually using OCR technology. We've then got your receipt and expense management tools like Expensify and QuickBooks, who use OCR to capture all of the details off your receipts. We can use OCR for things like scanning product catalogs, price lists, supplier documentation in order to actually keep an up-to-date inventory. And then we've already touched on this, but converting paper contracts, agreements, legal documents, manuals into searchable digital files. So OCR can be really, really powerful. But historically, OCR has often struggled with things like handwritten text, where the accuracy drops below 80%, or complex layouts with a mixture of text and images. So say, for example, where we have a chart, it's often not able to infer anything from the chart and we'll just take the text. Whereas now the OCR technology has improved drastically, especially over the last 2 years. We're going to run through 4 of the top rated free OCR tools and show you how they perform on the series of formats that we saw before. And I've chosen a variety of these formats because actually they represent often what are business documents from my experience with clients and my experience with my own business. So we've got a mixture of text heavy documents. So long research papers, for example, where we have multi-page documents. We're often not just scanning one thing in. We want a mixed content. So graphs, tables, images, etc. We want quality variation. So we want to understand how these models perform against the worst cases, not the best cases, because actually that's what really matters. How well is it going to perform for really illegible handwriting, for example, or degraded text? We've not got anything in a different language here, but the same applies. And we do have mathematical equations in the final document. And then we want to represent real world captures. So where you have to take a photo of something instead of a scan and you upload that, you want good output still from that and a high degree of quality or expected output. So I've gone ahead and I've set up all of these different test documents as PDFs and JPEGs, mostly JPEGs, actually, mostly images, apart from the last research paper, which is a PDF, inside our N8 environment. And we're just pulling those from Google Drive. So for example, if I just deactivate all these and I just execute that first capture, we can come in here and we can see this is stored as a binary file inside N8N, and we can view that and you can see that that was the capture. And then what I've done on the right hand side is put all of the nodes pre-configured if you want to grab the template and do this really quickly. All of the nodes, which are mostly API calls to these different models, which are supposedly some of the best models out there. And I've purposefully chosen free models so that you can access these really easily. And then we'll also cover inside this, often you will not have these available as a binary data file and you'll need to host them somewhere as a URL. So some models or some providers only accept a hosted image URL instead of uploading the file directly, especially through that API. So we'll show you how to host an image for free using ImageBB as well, so that the whole thing can be done for free apart from your standard N8N hosting. Now, before we jump into testing them, let's run through the 4 different models we're going to test today and why specifically I chose them. So first, we've got OCR.space. We've then got Mistral OCR. We've got Qwen 2.5 VL and NanoNets OCR. So all 4 of these from various sources have been ranked really highly, including this study done by GetOmni.ai, which actually you can see we've got Qwen 2.5 VL, Mistral OCR, and they've also got some other LLMs inside that. Now, they did their full tests using these LLMs and OCR models, using a really rigid approach where they took a document, had the OCR result, compared that with an evaluation model like GPT-4o, and then actually determined the adjacent accuracy. We're not going to be able to go to that detail in this tutorial, but what we are going to do is see it on real business documents and see the outputs firsthand from these different models to help you determine which one might be best for your use case. But ultimately, for various reasons, you're going to need to try all of these models in order to find for your use case which one's going to work best. So if we go to OCR.space, we've got a free OCR API key. So we can do up to 25,000 requests per month for absolutely free. And we can even output a PDF that's searchable at the end of it for us. So OCR.space has been operating for a while now, and they're really highly rated in the space. However, if you need more than that, you're going to need to move on to their paid plan. We've then got Mistral OCR. So Mistral OCR has been out for a few months now and has been heavily talked about as one of the best performing OCR models out there. And as part of their free plan, you can try out the OCR model. And then if you want, for example, 1,000 pages, then it's only going to cost you $1. So very, very cheap as well. And that's their document AI and OCR model. And Mistral has had some impressive results with things like the ability to read graphs and charts, which we'll show you. We'll then move on to Qwen 2.5 VL. So this one can be self-hosted yourself, or you can use a service like OpenRouter. But this has recently, in the last few weeks, been making waves in the OCR space as a model that's been fine-tuned on thousands of documents and is outperforming a lot of other paid services. And you can access this for free through something like OpenRouter, or like I said, you can self-host this locally and use that for free as well. And then finally, NanoNets has been something that's been highly trending on Hugging Face as one of the top used models in the last 7 days. So this is really recent. But NanoNets offer a series of different workflows that connect up to your different softwares. So you might not even necessarily need to use N8N to use NanoNets, because actually you can create workflows inside of NanoNets, but you're able to use that API and get started for free with $200 worth of credits in your account when you sign up. And NanoNets is actually built on top of Qwen 2.5 VL. So it's a specific fine-tuned model for certain types of documents, like financial documents, on top of that mod. So we'll see how that performs as well. So let's go through each of these and demonstrate the results. So we will start with the capture, and then we'll move on to the graph, the handwriting, the newspaper stocks, and the research paper as well. So what we're going to do is just connect up each of these specific nodes to each of the different channels here and activate them and let them all run at the same time so that we can see the results compared to each other. And when you're testing out different OCR providers, especially by API, often there'll be 2 types or 3 types of upload. The first is sending in a URL of an image that you're hosting somewhere. But often if you've got the files on your desktop or in your Google Drive like we have, we want to upload the file as a binary file, like an image or a PDF directly. So most of them will allow you to do this, but not all of them. So for example, when we're uploading to Qwen and NanoNets via OpenRouter, for example, here and directly through NanoNets, we're going to need to host the image as a URL. And the third method is actually base64 encoding it, which to be honest, for this tutorial is too complex. So we're going to stick with showing you how to host an image if you need to host one for a specific URL, for a specific API endpoint, or just uploading it directly as a binary file through N8N. So to host the image and upload it as a URL, which by the way, all of these models will allow a URL upload. So you might want to just host all of the images for ease. What we're going to do is use a service called ImageBB. And you can do this manually as well. You can upload an image. So if we click start uploading and we go to the OCR folder, what we can do is click on any image. It will upload directly in here. We'll put it on don't auto delete. We will copy the link that comes back and we will paste that into a URL to check that it's uploaded. It has uploaded correctly, but this is not the link that it's going to need. And that's not the link it's hosted at. So what you need to do is right click and open image in new tab. And that's going to give us the hosted URL. So if we go back to N8N, what we're effectively doing in this HTTP request is exactly what you've just seen on screen, but we're doing that via the ImageBB API. So we've got this URL endpoint in here. You need to add your API key inside a query auth parameter and call it key, and then add the key inside there. And then we're uploading an N8N binary file, which is called data, as you can see. And what that's going to return is effectively a URL that we can then use to pass into an OCR tool. So that is the method we're going to use for Qwen 2.5 VL and the NanoNets model. And you can see inside these HTTP requests, inside at this endpoint, we've effectively got, again, our header auth inside here, which has authorization, and then the header auth, which we'll show you later. And then all we're doing is passing the image URL, and that's going to come back with the respective text that it's extracted from that image that we're uploading. The same with Qwen 2.5 VL, where we're using OpenRouter to do this. And what we're doing is, again, sending it to OpenRouter, and we're just specifying the model inside the OpenRouter JSON here. And what we're going to do is just make this dynamic. So make this pull inside the image URL, and that's just dropped at the bottom there. So I'll just bring it up, and we're putting the URL in as a parameter there. Again, that's just hosting it as a URL where we had it as a binary file before. However, Mistral OCR directly and OCR.space allow you to just upload the binary file directly. So in the OCR.space, we've got a few different parameters in the form data here. It's a JPG file type. We want it to convert it in English. We want it to create a searchable PDF, which we'll see at the output end here. And we're just specifying that we're actually inputting a binary type of data, and exactly the same for Mistral, except Mistral is slightly more complex in the way that you need to request these. You first need to upload the file into Mistral. You then need to retrieve a URL of the file and then perform OCR on the file URL that's been uploaded. So it's a 3-stage process, but you can see again, we're just using this endpoint here. We are passing the header auth of Mistral OCR, which is a standard API key, and we're asking it to do the OCR function and showing it the data that it needs to upload. So what we're going to do is run that all 4 of those, connect them up and see how they perform on the capture, and then we'll run through each of the other documents as well. So to remind you, this is what the capture looks like. So CLIZIL. So this one should be fairly straightforward for most models to understand. And this is why people are worried about actually bots solving their captures on websites, because it's a security mechanism set up so that only humans can read them. So if we first go into the OCR.space result, we've got the different paths results here, and actually it's supposed to put the parse text inside of this field here. So you can see clearly that it's not worked, because actually it's output this searchable PDF, which we can open up right here, which actually has the image in. But if we try and search any of the letters C, we don't actually get any of this. So it's not understood that this is an image, and actually failed at the first hurdle of representing that image. Let's have a look at the Mistral OCR. So it's going to be this end one here where we actually retrieve or perform OCR on the image. And what we've got is effectively an output format that actually, if we go to the binary section here, it's output in a JSON, because it's recognized that there's some text in there, and it's given us this markdown of hashtag CIZ, which, as you can probably guess from the image, is actually incorrectly. So it's not done particularly well there. I wonder if we rerun this, if this will actually perform better another time. And let's go into view. Again, it's kind of understood it as hashtag CIZ. So not a great first go from Mistral or OCR.space there. And OCR.space still hasn't understood that there's any text to be searched inside there. So let's take a look at the Qwen model and see if that's performed better. And by the way, these captures are designed to be hard for computers to read, because otherwise you get a lot of bots reading them. So this one says the text in the image is Chiz, CHIZ, which again isn't quite correct, but you can see how it's inferred that from the characters. And it says it appears to be stylized or decorative text. Let's see how NanoNets has performed. And again, that one's failed. So it said the raw text is actually just TZ, whereas we can see clearly it is not TZ. So on the capture, all of them have failed, but on other things, these will perform much better. But you can see that actually they're still not perfect today. So the next sample we're going to test it on is actually very illegible, even to the human eye. I'm zoomed in here, and it's effectively like a few tables on a page that's clearly a poor photograph, poorly lit, hard to read. And it's also rotated as well, so it's even more difficult. And we've run that through each of the different OCR tools, and we've got OCR.space, and we'll open this up as a PDF again. But if I try to search any of it, it's actually just returned it as an image and not passed any of the text. So this is the second one that actually, if I look at the JSON results, no text has been passed from this. So I'm not sure if I'm using this incorrectly or it's just not working at all for the samples. We've then got Mistral. So again, it's output this as a JSON. So you can see in the markdown here, we've actually got a fair amount of text, and also it's actually understood that there are tables inside this text. Now, we're not going to go through every single line and check if it's correct, because this is just giving you a sample of the potential output. So you need to test it on your specific document types. But we've got fish and wildlife management practices according to a plan approved by a county conservation director. And if I zoom in there, I can see that is in fact the first text, fish and wildlife management practices according to a plan approved by the county conservative director. It's then got Article V, area, yard and weight requirements. And we've got Article V, area, yard and height requirements. So it even got better than me. And you can see that it's put this markdown as a title. So it's understood that this is a H2 title, and the next section, section V underneath, is a H3 title. And that means that actually, because it's converted it to markdown in this way, you could then turn this into a digital document that looks much like what we saw in the example above, where you effectively have have this markdown structure. So tables would appear like this, headers appear like this, rather than the document that's input as well. So really clear. So Mistral's done really well to get that there. Let's have a look at Quen. And if we go to the JSON here, we can see again, we've got F, fish and wildlife management practices according to a plan, article V. And again, this is put it into different titles here, or identified that it is bold by putting the markdown stars around it. Hasn't quite understood that this is a H2 header in the same way that Mistral has, but it seems to have picked up the table down here and a lot of the different information from that. So that's performed really well as well. And then NanoNets actually extracts it in terms of actual words down here, but also the raw text. But you can see that actually it's not quite understood the raw text here, and it's come out as kind of random characters together. So maybe NanoNets hasn't quite understood the brief there. So Mistral and Quen have worked really well, but NanoNets and OCR.space less so on this example. Now, if we run through the others more quickly, you get the idea of how these work and you can test them for yourselves. So we've got the handwriting 2 example here, which was this table of effectively different measurements and times. So we've got 3.75 miles, 7.5, 11.25, 15, and then underneath we've got various different measurements. So this one's in a table structure, which is going to be hard for it to format. And I actually went ahead and tried this out on NanoNets directly, as if I was just uploading this one document to see how it would output it through their website. And I was very impressed with the results. So I've uploaded it here, and you can see that the extraction from NanoNets is 3.75 miles, 7.5, 11.25, 15. And then even when we get down to the text, where this is quite illegible, 696, this is potentially 757. And this is really cool because you can see the outputs side by side next to each other. You can see it's not quite understood all of them. So under here where we've got potentially 8859, it's put a symbol here. But what this is going to do is eliminate 90% of the work and just allow you to check side by side and identify any potential differences, especially when it's so complex and the format is so hard to digest. But often what happens with these OCR models is you can have a specific template that an OCR model is trained on and learned to read. So say, for example, it was reading this, it would get better at understanding this specific template because we've identified what the column names are, etc. So you can upload it in bulk and multiple times. OCR.space has also performed actually for the first time in these tests, and it's pulled out all the different lines here and then labeled the past text, but it seems to have stopped quite short of all of the past text and kind of identifies the first line only. So we've got 3.75 miles, 7.5, 30, but it's missing kind of the basic understanding of the structure there. So still underperforming versus something like Mistral OCR. Let's have a look at the results quickly. You can see that this is really nicely broken down all of the different results. And if you pasted this into a markdown converter, you'd potentially see exactly the same table that we have here, but just in digital format. So OCR, and we've already seen NanoNets there. Now let's have a look at how they handle graphs when there's an actual image of a graph in there. So from quickly looking through the results here, when they're handling graphs, all of them have not performed particularly well. We finally got some past text again from OCR.space there, but the text was the easy to read part from here and actually shouldn't have been difficult for any models. Even Mistral, that prides themselves on being able to identify the context of certain graphs and images, has not pulled out anything other than the text down here. So you can see Mistral Small, a 24-bit parameter open source version, and that's all in the text down here. And inside the actual JSON request, Mistral has a specific parameter for this, which is called bbox annotation format, which is about identifying when there's an image inside an image uploaded or an image inside a PDF, it's supposed to actually describe in English the image there. So we put those in the parameters, but for some reason it hasn't recognized it via the API. So you might have difficulties doing that. Same with Quen and NanoNets. None of them have identified it. So for this example, you might be better off actually just using an LLM. And in a separate video, I'll cover which is better, OCR versus OCR via an LLM or a vision model in an LLM. But for now, for things like charts, you can actually just upload those separately to an LLM and get some feedback on the charts themselves, rather than using an OCR tool, which is all about bulk uploading these documents. Finally, let's have a look at the research paper. And we're actually just going to cover the research paper, which is a PDF instead of the image like the rest were, which means actually for OCR.space, we've not set it up to receive PDF documents, whereas all of the others we have. So we've got another branch in here under Mistral, which accepts PDF documents. And we've only set up Mistral to accept PDF documents. Quen and NanoNets also are only accepting images, but they're very easy to set up to also accept documents. You just need to change the parameter inside here, change the type image, for example, to something else. And that will be all in the documentation for OpenRouter, etc. But let's remind you of what the research paper looked like. And this is more complex and more like another business use case, which is actually a research paper or a legal document will often have some strange characters, but also not necessarily formulas, but also multi-page is often really important for our business. So I just wanted to demonstrate what this would look like coming through Mistral, for example. And again, we've got the OCR output, and we can also take take it away as a file, but that is just the uploaded file. So what we're going to do is load out the binary data there. And what we can actually do is just take this data, and you can see it split it into various different indexes. So it's saying there's no images in the first bit, and this is the markdown text. And what we can go to is a markdown to PDF, and let's just copy that into there. And we can effectively see the text in an easier format, although it doesn't look that easy there. We've got computing the theta function. And if we go back and we compare it directly to here, what you can see is you can start to break out all of the different text, which was as an image, is now available here as well. And if we put in all the correct line breaks, etc., then we'd start to see all of this text laid out. So some of the more complex bits are going to be let f rn 10 to r. And you can see it started to pick that up. It's actually got these mathematical symbols, which I wonder if we separate will actually turn into markdown. It's tried to actually, and it's understood that there are mathematical symbols in there, but it hasn't quite pulled out those mathematical symbols. And I don't know whether that's my understanding of how to get to them in markdown, or whether it just hasn't understood it correctly. But you can see it's picked up all of the information really clearly. It's just struggling a little bit with the actual mathematical symbols. But we can see by going back to the results here that it has, hundreds of markdown pages here, which you could automate to actually convert to digital documents, which again would be searchable versus the images that we input. So hopefully that gives you a good idea of 4 of the most powerful free open source, or often open source, OCR templates or models available, and how to connect to them inside N8N. If you want to work along with this video, like I said, jump into the community, grab the template. And the next video we're going to do is around LLMs versus OCR. And the next video we're going to do around OCRs is LLMs versus OCRs, and which you should use when. Because LLMs are becoming so powerful now that actually they have a lot of vision built into them. So should you actually not be using OCRs at all and actually just revert to using your LLMs, which have the context built in? Thanks so much for watching. Please like and subscribe if you enjoyed the content.